if you take NaCl, if you take NaCl and add to AgNO3, what happens? Immediately you see that the precipitate which comes away, right? Immediately, within seconds it comes, right? Second, I'm taking what? I'm taking the road, suppose laying of the roads. The cementing takes how much time to harden? It takes almost 2 to 3 days to harden, right? So 2 to 3 days it takes for the reaction to complete, right? Here it takes seconds. Now there are reactions, suppose rusting. Rusting takes how many years? 3 to 4 years it takes, right? So the very important portion we have to learn, that when we see the reaction, right? We have to understand that there are many fast reactions which take seconds, right? And there are reactions which take 2 to 3 days, right? And there are reactions which are taking 3 to 4 years, right? Isn't it? So it's a very important point we have to master, right? That if you see that when we see a reaction, right? When you say a reaction can be very fast. Suppose the reaction can be slow, and also you're saying that there are reactions which take years, right? So now understand that knowing how fast or how slow a reaction is will not make us okay, right? It's not okay that we have to know that exactly, that we have to know exactly how much fast or slow a reaction is, right? Knowing a fast reaction is, it is a fast reaction, slow, it does not help us. We have to know exactly how much fast or how much slow it is, right? So to understand that, we have to go into what? We have to go into the word called as rate, right? What's the meaning of the word called a rate? Rate is nothing but it's a measure of how fast or how slow a reaction is. Isn't it clear? You get my point? What's the meaning of the rate? Rate is a measure of how fast or how slow a reaction is. How fast or how slow rate. So if you utter the word rate, what is the rate means? Rate is the change happening per unit time. Is it clear to you? Do you get my point? If you see rate is nothing but the change happening per unit time. That's a very important point we have to master. What is rate? Rate is nothing but the change happening per unit time, right? It's a change happening per unit time. So if you see that, suppose we are trying to travel by a flight, it travels 800 kilometers in 1 hour, right? So change is what? Change is the distance. Can you see this distance? 800 kilometers distance is the change, right? And per hour, see, per hour, right? So time is how much? Hour. Change happening per unit time is the rate. Everybody is clear to you? Is it clear to you? Kanya, is it clear to you? Hitakshi and Chika, is it clear? What's the rate? Rate is the change happening per unit time. Change, right? It's the change happening per unit time. So that's called the rate, right? Now coming to the part, suppose you're filling petrol in Asda, right? It's filling up how much? 50 liters per minute. Is it clear? 50 liters per minute, right? So that's a very important portion we have to learn. It's the filling up petrol of 50 liters per minute. What's the change over here? 50 liters. And the time is how much? Minutes. So rate is nothing but the change happening per unit time. Suppose you are going to the printing press. The printing is printing out copies, right? Suppose it is printing out 10 copies, 10 copies per second, right? 10 copies per second, right? So the rate is how much? 10 copies per second. See the time unit? It can be hours, it can be minutes, it can be seconds also. But change happening per unit time is called as the rate. That thing you have to master, right? Now we go to the part of a reaction. What is the rate of a reaction? See, rate is what? It's a change happening per unit time. That's called the rate, right? Now, going to the next part, if you see that, suppose you quickly open your copy and write down. Metal plus acid, everybody write down. Metal plus acid gives you salt plus hydrogen. Please write down. After that, you write base plus acid, right? Base plus acid gives you salt plus water, write down. Fine. After that, you write carbonate plus acid, right? Carbonate plus acid gives you salt, water, and carbon dioxide, right? Is it clear? Did you understand this part? So if you see that when we utter the word rate, rate is the change happening per unit time. We have to know the three equations. Metal plus acid gives you salt and hydrogen. Base plus acid gives you salt and water, and carbonate plus acid gives you salt, water, and carbon dioxide, right? These three have to master, right? Is it clear to you, right? Did you understand this part, right? So now going to this part, if you see that in any reaction, right? Any reaction. Suppose I've taken what? Suppose I've taken a zinc. I've taken zinc. I have done what? I have actually taken zinc, right? Isn't it? And I've put it into acid, HCl, right? So I do what? I take a zinc and I put in the acid, HCl, right? Isn't it? I put in the acid. Now this reaction will be happening what? Metal plus acid gives you salt and hydrogen, right? That's the thing we're seeing. And hydrogen will be given out. And always remember over here, the practical part will be coming. Hydrogen gas is what weight? 2 grams per mole, right? So you'll be seeing that fine bubbles will be coming out, right? In the test tube, fine bubbles will be coming up. Now, if you see that, we are seeing carbon dioxide gas coming out. You have to know these differences. In the test tube, we'll be watching that carbon dioxide, how much? 12 plus 32 plus 32, right? No, 12 plus 16 plus 16. That is 44 grams per mole, right? Quite a fat gas, right? You'll be seeing the huge amount of bubbles will be coming out. Understood? Clear to you? A huge amount of bubbles will be coming out, right? So you have to understand the gases. Did you get my point? Hydrogen gas will be have fine gas because it's 2 grams per mole. CO2 will be bigger bubbles we are having, right? Isn't it? Now going to the next part, you see that when we talk about this reaction, right? That acid plus metal gives you salt and hydrogen. Can you see over here the observation? Fine bubbles will be coming out, right? Fine bubbles will be emitted out, right? Right. Now after a certain amount of time, can you see the bubbles emission slow down, right? Bubbles emission slowed down. And finally, the bubbles emission stopped. Is it clear? Do you get my point, right? Finally, the bubbles emission stopped. Totally, it stopped, right? Do you get my point, right? So over here, if you see that, when you see that in this reaction, can we predict the rate of the reaction by visual means? Yes. We can predict the rate of the reaction by two ways. Yeah, by visual means we can have a visual. That say at the start of the reaction, huge amount of bubbles is coming out. We slowed down as the reaction proceed and ultimately it stopped. So we can tell that visually the rate of the reaction is fastest at the start, slows down as the reaction proceeds, and ultimately it stops. Is it clear to you? Ultimately stops. So it's a very important part we have to nurture, that whenever we are seeing that any reaction, right, we are very sure that the rate of the reaction is fastest at the start, it slows down as the reaction proceeds, and ultimately it stops, right? Isn't it? Now, can we find out this by any other means? Yes, we can find out it experimentally also, right? That we're learning, right? Now, what do you mean by what called a rate? Rate is nothing but is the change happening per unit time, change happening, right? So if you want to find out the rate of this reaction, how can you find out the rate of this reaction? We can find out the rate of the reaction by either by measuring the amount of the zinc. See, I'm just trying to tell a very important trick, right? See, the reactants are used up. Remember that, right? Isn't it? The reactants are used up, right? And the product get produced. Is it clear to you? Did you get do you get my point, right? Reactants are getting used, always get used up, and the products gets produced, right? So how can you find out the rate of the reaction? We can find out the rate of the reaction by four particular method. First thing, we can find out the rate of the reaction by taking the zinc getting used up per minute, right? Used up per minute, we can find out. We can find out the amount of the sulfuric acid getting used up per minute, or we can find out the amount of the zinc sulfate getting produced per minute, or amount of hydrogen getting produced per minute, right? Any of these four will be giving you the rate of the reaction, right? Isn't it? So if you see that when we utter the word rate of the reaction, any one of them will be giving the rate of the reaction, right? Any one of them, right? Either we can measure the zinc getting used up per minute, or we can get the sulfuric acid getting used up per minute, right? Or the zinc sulfate getting produced per minute, or hydrogen getting produced per minute, right? You get my point, right? So over here we can find out the rate of the reaction by four ways. Any of them will be giving the same rate of the reaction. Now, please go to the Zoom chat and tell me from all these. See, I'm just telling you how you can find out the rate of the action. We can pick up the zinc that is getting used up per minute. We can pick up this zinc and we can measure it every 2 minutes. Again, put it back. Again, put it up. We can wash it. We can oven dry it. Again, put it back. After 2 minutes, we are finding the record. Or we can take out 5 centimeter cube of the H2SO4 and we can find out the concentration which is there, right? Concentration getting used up, right? Or we can do what? We can also find out the zinc sulfate, right? By precipitating it, right? We can take 10 centimeter cube and we can precipitate the zinc sulfate, filter it, and we can measure it. Or we can find out the hydrogen getting produced per minute. The same result will be coming. Now, can you go to the Zoom chat and tell me that which procedure will be easiest to do? Can you tell me? Please go to that Zoom chat, please. Which is the easiest to measure? Zinc H2SO4, zinc sulfate or H2, right? Hmm. Please try to send me. Okay, everybody send me. Everybody, I've got two only. Please, I've got two only, right? Wonderful. Kanya, please guide me. Please guide me. Type na. Type. Send a message to me. Send a message to. Yeah, perfect. Hydrogen. Why? Because other processes can be done. Agreed. But it's laborious. Did you get my point? It's laborious. So that's a very important thing we have to master, right? Now, going to this thing, suppose we are doing what? We are taking, we are trying to see the ways by which we can find out the rate of the reaction, right? So the ways by which we find the rate of the reaction is that whenever we are having a gas coming out, guys, gas, when you're having a gas coming out, hydrogen, right? Suppose you're having hydrogen coming out or carbon dioxide coming up, right? If a gas is coming up, right, coming out, whenever a gas is coming out, what happens? You'll be seeing that the gas can be taken in a gas plunger. Is it clear? We can allow the gas to come to the gas plunger, right? Fine. When the gases come to the gas plunger, what happens? The gas plunger moves backwards. There's a graduation over here also, right? There's a graduation over here. We can note down the amount of gases which is coming out, right? What we do? We take a stopwatch, right? We take a stopwatch and we can note down also, right? We can note down. We have to take a stopwatch and we can note down also over here, right? Isn't it? Now, if you see that when we are seeing this reaction, right? When you're seeing this reaction, we have to noting that the data. Please, everybody, stop me if you don't understand, right? Fine, please. Thank you so much. See, I'm just noting all the data. See, after every half a minute, I'm noting down the volume of the gases, right? Which is accumulated, right? Volume of the gases, right? Isn't it clear? Volume of the gases, right? Fine. Suppose, if you want to find out the rate of the reaction, right? See, observation, we found what? By the observation, we found out that the rate of the reaction is fastest at the start and slows down as the reaction proceeds. We learned that, right? The rate of the reaction is faster at the start and slows down as the reaction proceeds, right? Isn't it? Observation was that, right? Isn't it? That observation. Now, here to see that is the same found experimentally, it should be. See, what the rate of the reaction in the first minute? 14 minus 0 divided by 1 minus 0. Take, right? Understood this thing? It's 14. What the rate of the reaction in the second minute? We are having what? Final is 25, right? I'm just going to zoom in this. See, the rate of the reaction in the first minute is the 14 minus 0 divided by 1 minus 0, that is 14. In the second minute, what's the rate of the reaction? 25 minus 14 divided by 2 minus 1, right? Clear, everybody? Everybody clear? In the third minute, what is the rate of the reaction? 33 minus 25 divided by 3 minus 2 minutes, right? Understood? We can find it like this, right? So the first minute, what is the rate of the reaction? 14. Second minute, how much? 11. Third minute, how much? 8. Fourth minute, how much? 5. Fifth minute, how much? 2. In the sixth minute, how much? 0. Right? Clear? Understood? So we can tell that at the fifth minute, the reaction ended or reaction died, right? Clear, everybody? So it's a very important portion we have to learn, that when we see that in any reaction, right? In any reaction, the rate of the reaction is fastest at the start, we learned. It's fastest at the start. See, 14, 11, 8, right? And slows down as the reaction proceeds, right? So 14, 11, 8, 5, 2, right? It slows down as the reaction proceeds, right? So it's a very important portion we have to learn, right? Whenever we are seeing that in any rate of the reaction, the rate of the reaction will be fastest at the start and slows down as the reaction proceeds. From the experimental values also, we can know this, right? Experimental values, we can also know that, right? That the rate of the reaction is fastest at the start and slows down as the reaction proceeds, right? Now we are moving on to the graphical method, right? If you see the graph, right? If you see the graph, in the graph we are seeing what? In the graph we are seeing, we are trying to plot the graph, see? Now, see, over here plotting the graph. See, half minute, 8, right? So this is the time, this is the volume of hydrogen, right? Always remember, I forgot to tell you, In order to find out the rate of the reaction, you have to plot the concentration of the reactant or product per unit time, by time. This is a very crucial thing I'm trying to discussing, right? We have to plot the amount of the concentration and time, right? Isn't it? We have to plot the concentration with time, right? Isn't it? So if you just remember one thing, if you're plotting the product, right? If you're plotting the product, right? The product curve will be something like this. Is it clear to you? If I'm plotting the product curve will be something like this, right? Isn't it? Something like this, right? Did you answer this part, right? So the product curve will be something like this. Is it clear, everybody? Now, if you plot the reactant, right? If you plot the reactant, right? The reactant curve will be something like this, guys. See this. Please note down this quickly, right? Because the reactant gets used up, isn't it? So it will be something like this. You have to memorize these two graphs, right? If you see the product we are trying to trace, the product will be something like this, right? Concentration by time. If you're plotting the reactant curve, the reactant curve will be something like this, right? The reactant will be decreasing, right? The reactant decreases. So reactant divided by the time we are taking, right? Now, after we plotting the graph, right? After we plotting the graph, you plotted the graph. What did it tell you? In order to find out the rate of the reaction, you have to always plot the concentration versus time graph, right? After he plotted this, right? After he plotted this, right? What we do? We draw a tangent. Suppose I'm asking you that what's the rate of the reaction in the first minute? So you have to move the line upwards and you put a tangent over here, right? Suppose I'm telling that what is the rate of the reaction in the third minute? Again, we have to plot a tangent, right? Fine, over here. Fine. Is it clear to you? Now, if I want to find out the rate of the reaction at the 3.5 minutes, we plot a tangent, right? Can you see this? As the reaction goes on, the tangent gets less steeper and less steeper. Understood? Something like this thing happened, right? If you see, if the tangent, the steepness of the tangent will be telling you the rate of the reaction. Remember one thing, right? The steepness of the tangent, right? So as the reaction goes on, what happens? The rate of the reaction slows down. Observation we have seen. From the experimental data also we have got to know over here. We got to know. Now graphically you have to show it, right? Graphically. Steeper the tangent, please write down this. Steeper the tangent, faster is the rate of the reaction. Always remember this thing, right? If the tangent is steeper, faster is the rate of the reaction. This thing you have to master, right? Steeper the tangent, faster the rate of the reaction, right? Clear, everybody, right? Steeper the tangent, faster the rate of the reaction, right? Now, going to this thing, if you see that, suppose if you want to see a reactant curve, right? The reactant curve will be something like this. See, one minute. Wait, just 1 minute over here. 6. Just give me 1 minute. If you see that for the reactant curve will be like something like, because reactant gets used up. We are plotting the reactant concentration with time first. We have to plot that, right? After that, we are drawing a tangent, right? We have to draw a tangent, right? Suppose if you want to find out the rate of the reaction at 120 seconds, we plot a tangent over here, right? Understood? Now, if you want to find out the rate of the reaction at 60 seconds, right? We plot a tangent at this, right? Fine, over here. Now, can you all take the Zoom chat and send me which tangent is less steeper? That we wait. If you see that the reactant tangent will be there, right? The reactant tangent. So this is a reactant curve. So the less steeper is this tangent, right? Less steeper. So slower is the rate of the reaction. And blue tangent is steeper. So faster is the rate of the reaction. So we can tell that as the reaction goes on, what happens? The tangent gets less steeper and less steeper, right? Isn't it? Just remember one thing, that if you want to find out the rate of the reaction, how can you find out the rate of the reaction at 120 seconds? Just write down delta y divided by, write down, delta x. This is the rate of the reaction, right? You have to remember this thing, right? Delta y divided by delta x, right? Clear, everybody? Fine. Now, I'm just quickly going to the part that if you see that when we talk about the different ways by which we can find out the rate of the reaction, right? One way we understood, see, if a gas is coming out, we can take the gas in a gas plunger, right? And measure the rate of the reaction, right? We can take the gas in a gas plunger and we can measure the rate of the reaction easily, right? Isn't it? And we can plot the graph. Suppose if carbon dioxide is giving out, right? I'm giving this part. Carbon is a very heavy gas, right? We can take this in a gas plunger. Suppose we are taking carbonate plus acid gives you salt and water plus carbon dioxide. We can take this in a gas plunger and also measure it. Okay, carbon dioxide we can do. But there's another way, right? What's the another way? The another way is that we can take that substance on a this is a 6 marker question, right? Right, 6 marker question. Please note down this part. We can take the reaction vessel in a balance, right? Clear, everybody? Hmm? Fine. We can take the reaction vessel on a balance, right? On a balance, weighing balance, right? We can take this on a weighing balance. Now, after we taking the weighing balance, we are allowing the carbon dioxide to escape, right? Like this. We are allowing the carbon dioxide to escape. We are discussing that what are the ways by which we can find out the rate of the reaction by experimental process easily, that too easily, not laborious way. We can also measure the calcium carbonate, right? Every 2 minutes we can pick up, we can wash it, we can oven dry it, weigh it, again put it back. Laborious process, right? It's a very laborious process. So can we do something else? Yes, we can do. What we can do? We can let the carbon dioxide escape. Now the question comes: that what's the use of this cotton wool? The use of the cotton wool is that there will be lots of burping, right? Lots of bubbles coming out, right? Lots of bubbles. I told you, now carbon dioxide is a very heavy gas. Now, guys, you can remember. Do you know what? If you open a fresh, suppose a Coca-Cola bottle, what do you observe? When you open it hurriedly, what happens? Did you see? The carbon dioxide gas is coming out. Carbon dioxide gas is a very heavy gas. See? Large bubbles. You can see the bubbles. And carbon dioxide also splashes out the Coca-Cola out, right? Can you see that the Coca-Cola also it was dragged out? Because carbon dioxide is a very heavy gas, very powerful gas. It splashes out the liquid. So similarly, the liquid can splash out. So that's the reason we are taking a cotton wool, so that it can come back, right? Isn't it? So we are plotting the graph. So with time, the mass of this weighing balance will decrease, right? With time. So like this will be happening, right? We can plot the mass of the vessel with time. It'll be graph like this. Is it clear? Did you answer this part, right? So this is one of the way by which we can measure the rate of the reaction experimentally. When a heavy gas is coming out, carbon dioxide, we let the gas escape, and then we can very well do it, right? Now come to the part. Next part I'm doing what? Next part I'm taking this particular reaction, right? This reaction I can go to a book quickly. See over here. See, we just did this. That if you go to this yellow, all the violet marks will be coming, right? These will be all violet marks will be there, right? The 6 marker question, right? So go to the violet marking. See, now we did this. So we take the calcium carbonate and HCl, we put it in a conical flask, we let the gas escape, right? And we plot the mass which is decreasing, right? After plotting, we can draw a tangent, right? We can draw a tangent and find the rate of reaction. I didn't tell you a very important thing. Do you know what? If you see a product graph or a reactant curve, after drawing the plot, right? After drawing the concentration, right? What you do usually, the rate of the reaction changes with time, right? It's not constant. What we do, we plot a tangent at t equal to 0. Please, everybody can write this. We plot a tangent at t equal to 0, right? This. So this delta y divided by delta x, this is gives you the rate of the reaction, the entire reaction. Because every other point, the rate of the reaction will decrease with time, right? Do you get my point? So with the reactant curve you're drawing over here, every point the rate of the reaction changes, we saw. It's not constant. So how to represent this rate of the reaction? After plotting the reactant curve, we draw a tangent at t equal to 0, like this. So this delta y divided by delta x, this gives you the rate of the reaction, right? So in this particular portion, we learned that what rate is. The rate is the change per unit time. What the rate of the reaction means. We found out that visually we can observe, right? And experimentally we can find out from the data, or best ways to plot the graph. Now, this thing we did, right? If a volume of a gas is given off, we can find out the rate of the reaction, right? Isn't it? Now, this thing you have to do as a homework. I'll be going to that part again, right? I'll be going to this part again with you. This part, do it as a homework, right? That's just to write down the equation, right? Na2S2O3 plus HCl. Please to write down this, right? I'm just let me give you a homework, right? Na2S2O3 plus HCl, right? Have you written this? Na2S2O3 plus HCl gives you what? Can anybody guide me? What does Na2S2O3 plus HCl gives you? Anybody tell me? Will anybody tell me? Just write down this quickly. Na2S2O3 gives you NaCl. Please write down NaCl plus SO2 plus H2O plus sulfur. This reaction you write down. Please open your books. Please open your book. Please open your book. Please. Page number 129 and write down. Na2S2O3 plus HCl gives you NaCl plus SO2 plus H2O plus S, right? This sulfur is a precipitate. Fine powdery precipitate, right? Fine. Just do this as a homework, right? Fine. So just go through this portion, right, guys?